Yeah, so chapter 10 is talking about regression and correlation. Okay. Uh, the last chapter 9, we compare to population, right? And see whether there is a difference between the two population. Okay. And that is so in order to compare the two population, we have like two random variable, right? That are similar measures. Okay. So in this chapter, we will look at two random variables that are not similar and see if there is relationship between the two variables. Okay. So to do this, we need to look at the regression, which find the linear relationship, and correlation, which is measure the strength of the linear relationship. Okay. So the regression is looking for the linear relationship, and correlation is looking for how strength is the linear relationship. Okay. Um, so, but you have to remember, actually, there are many kind of relationship, but in this chapter we only discuss the linear relationship. Okay. Uh, so first is we talk about the regression. Okay. So the regression here is what we would like to answer if there is a relationship, and the correlation is answer how strong the linear correlationship. Okay. So in this case, the regression is only we talking about only the linear relationship. Okay. Uh, so for example here, determine if there is a relationship. Okay. So between the alcohol content and the number of calories in 12 ounce beer. Okay. So to determine, so we need to take one random sample for the alcohol and also the calories, right? And we got the data like this. Okay. So you can see here, this is the brand, this is the brewery or the company, right? So the brand is this, and this is the company, right? And this is the alcohol content in terms of percentage, and then the calorie in terms of the ounce. Sorry, the calorie is in, uh, yeah, in 12 ounce. Okay, so what is the calorie in that contain in 12 ounce? So this is the number of the measure of the calorie in the 12 ounce. Okay. So to find the solution here, to find the relationship here, we need to use, we call it a scatter plot. Okay. So this is the scatter plot. So this is so the relations between the alcohol content and the calorie content. Okay. So in the horizontal line represent the alcohol content, and the vertical line is represent the calorie content. Okay. So for example, you can start with alcohol content. So in this case is, let's see. Yeah, so the alcohol content, for example, like a fort so okay, the small one will be this one, right? So you can see it is like 0.4, right? So if the alcohol content is 0.4%, the calorie is 70. Okay, so you can see here 0.4 is like this point here, right? And the calorie will be like around 70. So 70 is like around here. Because like between these two, it's like 75, right? So 70 is close to this one. Okay. So this is for 0.4 and 70. Let's see what for this one. So this one is like 4 something, right? So you can see, yeah, you have two here, 4.7, and to have how many 4 here? You have 4.1, right? And then you have 4.7 and 4.72, right? Okay. So you can see 4.1. 4.1 you have 104, right? So 4.1 you have 104. So you can see here this is like 4.1, right? So you have 104. 104 is like around this point, right? Okay. And you can see for 0.7, yeah, this is like 5, right? So 0.7 is like around here, right? Okay, so you have see for 4.7 you have 2 here. You have like it's like you can see like 157 and 160, right? Okay. Yeah, you can use Excel to draw this picture, or you can use R program. Okay. I think in the book is using the R program. You can see the 4.7 is 163 and 158, right? So you can see that this two numbers is the same, right? I mean, it's almost the same. I mean, it's close. Yeah, you can see from the picture here, 4.7. 4.7, you can see you have to point that this close to each other, right? Okay. And you have like around 5 point something. Right? You can see from the data here, you have like around 3, 1, 3, yeah, was 5.1 and 5, and then 5, right? Okay. So you have a 3 point that is close to each other, around 5. Yeah, so when you make the scatter plot, right? So you can see here the X is the alcohol content in the beer, and Y the calories in the left on beer. Okay. So this is the scatter plot. Okay. So you can see also the scatter plot is like look like a linear, right? It's like if you draw straight line from here to here, it's like straight. It's, so the point is around a straight line. Okay. You can so that means the relationship is a linear relationship. Okay. So now you need to find the equation for the linear relationship. Okay. So the process of regression is used to find the line that best fit to the data. Okay. Or sometimes we call it the best fitting line. Okay. Yeah, so the process is like draw the line through the data and then find the distances from a point to the line, which is called the residuals, right? Okay. So the recursion line is the line that makes the square of the residual as small as possible. So the recursion line is also sometimes called the least square line. Okay. So you can see from figure 10.1.2. Okay. Yeah, you can see here. So the difference between if this is the line, right? This is point. So the difference is like the residual will be the difference between this and this. Okay. The difference between you can say this is y hat, this is the y. So y hat subtract with the y. And yeah, oh, the other way around. As it is, we call it the residual. So so the regression line is like this one. This is like this is the regression line. Okay, and the slope is using this formula, and the y-intercept using this formula. This is like the mean, the y mean subtract with the slope times the x mean. Okay, or x average or ny average. Okay. So this is formula to find what is the xy. Is this xy is like x minus x bar time y minus x bar. Right? And for the SSX is like s minus x bar square, and for the SSY is y minus y square. Okay. And there's a, we call it the independent variable, or we call it the explanatory variable or predictor variable. Okay. And the other one is will be the dependent variable. So the dependent variable, it depends on what independent value you pick, right? Or we call it the response variable. Okay. So this is the formula for the population equation. Okay. So this is the set of ordered pairs is a random sample from population of all such possible XY pair. Uh, so you can see also we need to assume also that for each fixed value x, the y value have a normal distribution. Okay. So all of the y distribution have the same variance, and for the given x value, and the distribution of the y value has a mean that lies on the least square line. Okay. Uh, yeah, so it is difficult to figure out. Okay, so you can use the following to determine if you have a normal distribution. First is looks to see if the scatter plot has a linear pattern, and two, examine the residual to see if there is randomness in the residuals. Okay, so if there is a pattern that of the residual, that there is an issue in the data. So if there is a pattern to the residual, then there is an issue of in the data. So it should be random, right? Okay. So there is no pattern. Like, for example, like you know, the pattern means that it follows certain formula, like for example, like 2x or x squared, something like that. Okay, so this is another the example of how to find the equation of recursion line. Okay. So you can use the scatter plot, right? Also you can use this formula. Okay. Yeah. So yeah, I will show you using this is using the calculator. Okay. So and I will show you how to use the Excel. Okay. Yeah, using the calculator, you need to put the X data in the X list or L1, and then the Y data, or you can put in the Y list or L2. Right? Okay. Yeah. So I will not talk about it. Okay. So you can, if you want to use it, you can use it, but I prefer to use the Excel. Okay. And also you can use R. Okay. So you can see this is the intercept. This is the gradient. Okay. Or the slope. So the slope is the number that's in front of the x. Okay. And this is the y-intercept. But the number is not in front of the x. Yeah, so this example for how to find the regression line, some of that, okay, using the calculator and also using our program. Okay. Yeah, interpolating is if the data is within the range of the original value, we call it interpolating. Okay. So if the outside, we call it extrapolating. So usually we use interpolation in order to find the in order to predict the values. Uh, yeah, you can see here if the slope is like this, right? So that means the calorie increase 26.3 calories for every 1% increase in the alcohol content. And the ratio is the actual subtracted with the predicted. Yeah, yeah, so this is another example using the formula, right? You know, if you want to use the formula, that means it's like you do it manually, okay? So you need to do like one by one, okay? So like you need to put the alcohol here, and then put the calorie here, and then you define what is the mean down here, right? And then looking for what is the difference between the x and the mean, and put it in this column. And what is the difference between the y and the mean, and then put in this column, okay? And then you can square it, or you can multiply them. If you add them, you got SSX. If you add this one, you got SSY, right? And for this one, you got SSX1. And you can see the formula is the slope is will be the SXX, the SSXY divided by the SSX. Okay? So you got this one. And to find the intercept, you just simply, so this is you want you do manually, okay? But in the Excel, it's easier. You just use the formula and you can find out the answer, okay? I will see you little bit, okay? Yeah, I will show you in a minute, okay? Mm. So this is about regression. So the regression is looking for the correlation, okay? You can use the graph or you can use the formula, okay? And the next part of this chapter, section 2, we're talking about the correlation. Okay? So a correlation exists between two variables when the variable of one variable are somehow associated with the values of the other variable. Okay. So when you see a pattern in the data, you say there is a correlation in the data. Okay. So in this book, we only talking about the linear pattern, not the exponential or something like that. So to see the pattern, you can use the scatter plot, right? Okay. So you can see here. This is, we call it a moderate positive. So like if the point is a little bit scattered around a straight line, like this is go from here to here, from left to right is like up. Right? So this moderate positive correlation. If this is close to a straight line like this, we call it strong positive. And if this in one line, in a line, so we call it perfect positive correlation. Okay. If go like this, from left to right is moved down, okay, so this negative correlation. And this is, we call it, if you scatter all over the place, it's like, we call it no correlation. Okay. And for this one is non-linear correlation because it's not straight line. Right? So you can see here the linear correlation coefficient is a number that describes the strength of the linear relationship between two variables. Okay. And we call it the Pearson correlation coefficient after the person named Carl Pearson, okay, who developed it. Okay. And the symbol for the sample linear correlation coefficient is R. And the symbol for the population correlation coefficient is, we call it rho. Okay. Okay, so this is the formula. Okay. So the formula for R is R equal to SSXY divided by the square root of SSX times SSXY. You know the formula like this, right? But this is if you want to do manually, and so using Excel is easier. Okay. So this is how to interpret the coefficient correlation. Okay. So the R is always between -1 and 1. Okay. So if R equal to 1, if R equal to -1 means there is a perfect negative linear correlation. Okay. And if R equal to 1 means there is perfect positive correlation. Okay. And if R is closer to 1 or -1, so closer R to 1 or -1, the stronger the correlation. Okay. And if R is closer to 0, we call it a weak correlation. Okay. So you have to be careful here for R equal not for R equal to 0 does not mean there is no correlation. Okay. It is just mean there is no linear correlation. Okay. There might be a very strong curve pattern. Okay. Okay. Yeah, so this is a sample how to calculate the correlation coefficient. Okay. I think this in this book using the calculator and also using the R program. Okay. Yeah, also you need to be careful here. So one common mistake people make is to assume that because there is correlation, then one variable causes the other. Okay, so this usually not the case. Okay, that would be like saying the amount of alcohol in the beer causes it to have certain number of calories. Okay, so no. Okay, so this is not the case. So actually, what is the fermentation of sugar is what is caused the alcohol content, right? Not not the calorie. Okay. So the more sugar you have, the more alcohol can be made, right? And then the more sugar, the higher is the calorie. Okay. This is actually the amount of sugar that cause both. Okay. Not not one affect the other. So do not confuse the idea of correlation with the concept of causation. Yeah, for example, like we want to find the correlation between coming to the class and raining, right? So it doesn't mean if it's less student during the, I mean, it doesn't mean that if the during the rainy day will be less student come to the class, right? Okay. So this is not the cause effect. Maybe it's just coincidence. This is another example that correlation doesn't mean causation. Okay? So this is another example. Okay? So studies show that there is a correlation between people who have had a root canal and those that have cancer. Okay? So does that mean having a root canal cause cancer? Yeah. So no. Okay. So so because there is a positive correlation doesn't mean that one causes the other. Okay. It's turned out that there is a positive correlation between eating carrot and cancer, but that doesn't mean that eating carrot causes cancer. Okay. In other words, there are lots of relationship you can find between two variables, but that doesn't mean that one causes the other. Okay. So this is another about the variation. Okay. So the total variation is equal to the explained variation plus the unexplained variation. Okay. So the proportion of the variation is using this model. Okay. This we call it the coefficient of determination or R squared. Okay. So you can find the coefficient correlation using the coefficient of determination. Yeah, just simply so find the coefficient variation in calorie that is explained by the linear relationship between alcohol and content and calorie and then potato value. You know, if you have the if the calculator you find this one, right? And also if you use the R is you got the same number here. Okay. So you can take the square root to find out the correlation value. Okay. Yeah, if you want to find the R square, you just need to find the correlation coefficient first and then square it. Okay. So you can see here 53.44% of the variation in calorie is explained to the linear relationship between alcohol content and calorie. Okay. And then the other 16.53%, sorry, 16.56% of the variation is due to other factors. Okay. So 83.44% of the variation is in the calorie is because of the relationship between alcohol and calories. Okay. But the other one will be the variation is due to the other factor. So you can see here, so you can see a good question of determination has a very small unexplained part. Okay. Uh, okay. Yeah. So the same thing there. Just using the formula, but in this case, we will not use. We will not, calculate manually. Okay. Okay. So there is the third part here, or the section 3. Okay. The section 3 is talking about the hypothesis test for the correlation and regression. Okay. I want to test whether there is a correlation or there is no correlation. Okay. So this is the step. So one is you need to state the random variable, right? So the x is the independent variable, the y is the dependent variable. Okay. And then you can assume if the correlation, if there is no correlation, or if there is a negative correlation, or if you have the positive correlation, something like that. Okay. And then you need to state the alpha level or the confidence level, right? Okay. And you need to state and check the assumption for the hypothesis test. So the assumption for the hypothesis test are the same assumption for regression and correlation. Yeah, the assumption is very, there's no correlation, or the correlation negative or positive and all that. Okay? And then you need to find what is the test statistic and also the p-value. Okay, so you can see here, this is the formula for to find the test statistic. So the test statistic, or t, equal to r divided by square root of 1 minus r squared divided by n minus 2. Okay? And you can see here the n minus 2 is equal to the degree of freedom. Okay? For the previous problem, the degree of freedom is n minus 1, but for this case, the degree of freedom is n minus 2. Okay? So here, be careful. Yeah, so this is a formula for you use the calculator. It is a formula if you use the R program. Okay? So the conclusion is, yeah, it is the same thing, the conclusion. Okay? So if the rule is, if p-value less than alpha, then we reject the S naught, right? Or the null hypothesis. Okay. So if the p-value greater than alpha, then we fail to reject the X null hypothesis. And then the interpretation is the same thing like we did before. Okay. So there is where you interpret in real world term the conclusion to be the test. Okay. So the conclusion for hypothesis testing is that you either have enough evidence to show its alternative is true, or you do not have enough evidence to show that its alternative is true. So this is the example using the same data. Okay. So in this example, uh, is there a positive correlation between alcohol content and calories? To determine if there is a positive linear correlation, a random variable was taken of beer alcohol content and calories for different beers. Okay. And the calorie beer, you need to go back to the table 10.2.1. Okay. And we try to test with 5% level. So because positive correlation, that means that's R I mean, the row is greater than 0, okay? Because it's positive correlation, right? And this is the significant level. And we already know that is what is the assumption of the participants. We need to go back to sample 10.1.2. And after you use the calculator or the R program, you can find the test statistic is this one, the p-value this one, right? Okay. And if you want to use the R for the test here, you need to pick what? R greater than 0, right? Okay. Yeah, so you need to pick R greater than 0. Yeah, okay. So the T is the test statistic and the P is the p-value, okay? You can see the degree of freedom is 7 because the data is assessing 9, right? Okay. So the degree of freedom is 7 because the data is 9. Right? Yeah, so there's another one. Yeah, so because we reject the S naught or the X, I mean, because we reject the S null or S naught, okay? Because the p value is less than 0.05, right? Because, you know, for this number, if you want to change to decimal numbers, you need to move the dot many times, 4 times, right? So 1, 2, 3, 4. So you have a 30 before 2. Okay. So you have 0.000288. Okay. You want to change this number to decimal number. So you can see the p-value is less than alpha. So that means we reject the null hypothesis. Okay. And the conclusion will be there is enough evidence to show that there is a positive correlation between alcohol content and the number of calories. Okay, so this is another problem here. I'm not sure if we use it. Okay, so I think I will skip this one. Yeah, this is looking for the confidence interval. Okay, so yeah, so this is you want to use a confidence interval. You can use this formula. Okay, let's go to the homework. Okay. Yes, you can see there's also we're looking for the confidence interval. Okay, let's go to the problem for chapter 10. Okay. Okay, let's start with number 1. Okay, so I need to Download for chapter 10, right? Okay, chapter 10 is this one. Okay, now let's look at. I will use the Google Spreadsheet again. Okay, I will upload it here, and you can use it. You can copy and then use it. Okay. So, any questions so far?
No, sir.
Okay. Okay, let's see. Yeah, it is number one, right? Okay, so start at number one. You can see this correlation coefficient will be in here, the comma or the comma. And okay, so you need to copy the data from the problem to the Google Spreadsheet or the Excel. Okay. Okay, so copy, paste it here. Okay, you can see you don't need this one, right? Okay. You can highlight it and then delete it. So you can see now. So your data up to 13, okay? From 4 to 13. Okay, so make sure you have to be here from 4 to 13. Okay? And you see that this is the formula equal correl and then the first set of data, comma, the second set of data, right? And then enter, you can find the correlation coefficient. Okay. So this will be the correlation coefficient for number one. So let's put it here. Round it to 3 decimal places. Okay. So that means you have 0.835, right? Okay, let me set this in the chat so you can use, you can copy and use it. Okay. Yeah, so put it in the chat and then you can copy and use it. Okay. Okay, so this the spreadsheet for chapter 10. Chapter 10 homework. Chapter 10 homework assignment. Okay. So go to number 2. Yeah, sorry, I didn't put in order. Okay, so for this one, you need to looking for what is the recursion line. Okay. Yes, it's the same thing. You just need to go to number 2 and then copy the data, right? Copy the data, put it here, right click, paste it, and you see you don't have down here, you don't have this one, right? You don't need to have this one, right? Yeah, apparently your data is like really small, the data that I have here. You're not looking for, this is will be the slope, okay? And the slope, the data is from 5 to 10, right? Okay. So this was from 5 to 10. Okay. So I put the Y data first. I think it's the same method what so you can flip the order. Okay. So this will be your slope or gradient, and put it here at least 2 decimal, right? So because say at least, so you can put everything. Okay. Control and then paste it here. Yeah, because it said at least, so you can put everything. Okay, so this number 2, number 3. Okay, for number 3, uh, we know the regression. Yeah, you need to find what is the regression to determine if there is a relationship between hours of TV watch per day and the number of sit-ups a person can do, right? Okay, so the result is like this. So the A is this number, the B is this number, and then the R is this number, right? And then you looking for use this to predict the number of sit-up a person who watch 10.5 hours TV. Okay. So you can see here the number of sit-up is the Y, right? And then the hours of TV that the person watches the X, right? Okay. So look, you're looking for the Y here. I mean, yeah. So you're looking for the Y or the number of sorry, the number of sit-up, right? So you just simply put the X to this formula. Okay, so you can see here. Uh, so you know the one that I'm teaching is let's go number 3. Okay. So the one that I'm teaching is this number. Okay, this number. That's it, and you will get the answer here. Yeah, put you need to put the number here is equal to this. Yeah, you can highlight and then put it here. Okay, and then you can highlight, copy, and put it here. Copy paste. Okay, and you can see you already had the formula here. Okay, so this is like the A, this is the X, this is the B. Okay, so in this case the X will be not 14, the X will be what, 10.5, right? Because you have 10 hours, 0.5 per day, right? watching the TV. So this will be answer for the Y, or the number of setup a person who was 10.5 hours of TV. Right? So the answer will be 10.6. Right? So the answer here 10.6. Okay. And the next question. Yeah, again, you just need to copy this and then place here. And erase the one that you don't want it, right? Okay, so it's just highlight it and then press delete button. And now you need to change. So now the data is from 4 to 13, right? So the level of significance here is 0.01, right? So the same, right? And you need to change this to 13, right? V4 to V13, okay? Maybe you got the name number, the same number, right? Okay, so number of data is 10. Okay? And this we need to change also to 13. Because you have data from 4 to 13. So I think this one is automatically calculated. Okay? So because the absolute R is greater than absolute, or greater than RCV, okay? So the answer is there is a significant correlation. You can see also this one is like close to 1, right? So that means there are, they have strong correlation because it's close to 1, right? Okay, so what you need to put here? The answer is yes. Okay, so because the R is close to 1, so the answer is yes. So there is a significant correlation. Okay, so the next one, number, you just need to see here, because this, so that means this is the correlation will be positive, right? Because from left to right is like move up. Okay? And you can see also, yeah, you can watch the video, okay, if you want to. Okay, well, let's try here. Yeah, you just need to understand, yeah, for the R greater than 0, if it's close to 1, so is that mean the positive strong correlation, otherwise it's a weak correlation. Okay. So for this case, this is positive, so the answer should be, it's not this one because it's like, it's not scattered everywhere, right? Also, it's not this one. I think that this one is like close to, like cluster around a straight line, right, from here to here. Okay, so the answer should be this one here. Okay, so this is we has strong correlation. You can watch the video if you want to. Okay. Okay, so the next one, yeah, for this one is simply take the square root of this. Okay, but you have to be careful here. the correlation negative or positive is depend on the slope. Okay, if the slope negative, so the correlation negative, so the answer here will be negative. Okay. The negative or the square root of this. So let me copy this. Oh, sorry. No, apparently I cannot copy it. So it's 0.7396. Zero 0.7396, right? So this is the R square, okay. So this should be, in here you should write R square. R square equal to that one, okay. So the R will be the square root of R square, which is C3, okay. So because the slope is negative, so the answer should be, the correlation also negative, okay. So I think I need to erase this. So this one should be the R, okay. So the answer will be this one. Okay, so the next one. Yeah, so far so good, right? So just copy this one, okay. And then paste it for number 7, right? Put it here, right click, paste it, okay. And it is that you don't need to. I mean, it is the one that you don't need it. Okay. It is the one that you don't need. So make sure you know change the data is from 3 to 14, right? So from 3 to 14. So I need to change this to 14, right? This one also to 14. And you got that number. So the answer will be 0.329. 0.239. Okay, let's see here. Zero point 329. Oh, okay, sorry. 329. Right. Yeah, I put the wrong number. So yeah, the next one will be, yeah, the same thing. Okay. Okay. For this one is simply because you're looking for percentage. Okay, so if you have r equal to negative 0.092, so you just need to square this, okay, and then multiply it by 100%, right? Okay, so let's copy this and put the answer for number 8, right? Oops, I'm doing it. Okay, I need to. Oops. Yeah, I don't know. Maybe I need to type it. Okay, let me see. The negative 0. 0.92, right? Yeah, apparently I cannot copy and paste, okay, so I have to type it. Okay. So this is will be, after you square it, and then you multiply by 100%, that's you got this number here, okay, down here. Okay. So the answer will be 0.8, okay. 0.8%, you need to multiply by 100%, okay. And number 9, the same thing, like copy. Number 9. It is the one that you don't need to. Okay, apparently this data is okay, so the last data is 46.4, 60.4. Okay. Yeah, so so you can see here the data from 3
Excuse me, sir.
15. Yeah, so from 3 to 15. Okay.
Excuse me, sir.
Yes.
I tried to do number 8, but I don't know how you did it.
Yeah. Okay. All right.
Can you
So
just go back a little bit?
first you need to find the correlation. Okay. Let me finish this one first. Okay. So first
Okay.
you need to find the correlation, right? Okay. Or the correlation coefficient, which is R. Okay. And then to find the R square, you simply just square it, right? You can see this formula. You see here the R is in E3, right? If you square it, you got the R square here. Okay. And then down here, you multiply by 100%, so you got this number here. Okay.
Oh, okay.
Okay. So the number that you need to put is this one, 74.7. Okay, let's see here if I can copy and paste it. Yeah, so you can copy and paste it. Copy this and paste this here. Yeah, you can put like 3 decimal places, right? So the answer will be negative 0.864. Okay. And as you square it and then multiply by 100, you got this number down here, 74.7. Okay, and submit it. So this number 9. Okay, for number 10 is talking about, you can see if you draw kind of line, like if you draw kind of line, you can see the line is very good like this, right? Like move down a little bit and then move up and then move down a little bit, right? Okay, so you can see this not linear. Okay, so is the Pearson correlation coefficient an accurate measure of the strength of linear relationship for this data set? The answer is no, right? Because it's not linear, it's not straight line. Okay. So the answer is no. Okay, let's see number 11 here. Yeah, number 11 is determine if there is a linear correlation, right, between the two variables at significant level 0.001. Okay. So the same thing, you just need to copy this. Oh, sorry. Right click, copy, and then paste it to the example number 11, right? Okay, just put it here, right click, paste it. Okay. And you can see your data is from 4 to 4 to, sorry, I cannot see this. 4 to 25, okay. So the data is from 4 to 25. So from 4 to 25. So you need to make sure this is 4, this is 25, this is 4, this is 25. Enter. Okay. And again, the same thing. So this one is from 4 to 25. And this automatically calculated to find the t-score. Okay. You can see if you have the data 22, the degree of freedom is 20. Okay. Okay, so that's the t-score automatically calculated. Okay. Yeah. Yeah. Okay. So this is will be the p-value. Okay. Because it's not equal, or the question is if there is a correlation or not, no correlation. So that means the claim will be not equal to 0, right? If there is no correlation, that means if there is no correlation, that means it's not equal to 0, right? Okay. Or two-tailed test, okay, because not equal, right? So for not equal is two-tailed test, so you use this one, okay. So yeah, this is two-tailed test. So I want to answer and for decimal, so the answer, the p-value will be 0.0092, right? Okay. Let's see. I need to put first. Okay, so first you need to put the coefficient correlation, which is the R, right? So the R is this one. Okay? Copy this, put it here. It didn't say anything, right? If you want to round up or something like that, okay, so just to copy everything. Okay? And this is the t-score already calculated. Okay? And the p-value will be this one, right? Okay. Now the alpha 0.01, the p-value is 0.09. So that means the p-value greater than alpha, right? So because the p-value greater than alpha, so that means is fail to reject. Okay, so the answer will be there is insufficient sample evidence to support the claim, right? Okay. Okay, so now we continue with number 12, right? Yeah, so number 12 is okay, sorry, number 12, right? Go to number 12. Yeah, the same thing. Put it here, right click, copy, paste. So you can see the last data is like outlier because look like different compared with the other data, right? Okay. So in order to find the So if you want to put with outlier, so the data will be from 4 to 18. Okay. So the one with the outlier, you need to put from A4 to 18. And the one with the outlier, so you need to put from, okay, I think you can use the same data here, but you need to change this one to A, right? So put A, this is B, but it's not include the last data. Okay, so this is with outlier, this is without outlier. Okay, so what is the conclusion here? You can see the correlation coefficient is from 0, is with outlier 0.0888, right? And without outlier is like increase, but it increase a little bit, like 0.3. Okay. So that means so the conclusion here will be what? Let's see. Yeah, I think you need to put the number first. Okay. So put the one with the outlier. Put it here. And then put the one with the outlier is shown here, right? Okay. So this one without outlier. Okay, so yeah, you can see as you compare this to the increase is like 0.3, right? So what do you think? Because for this number, we consider this is like weak correlation, right? Weak positive correlation. Also, this one is like weak. This is still close to but this one is like close to 0.4. This one is close to 0.1 or close to 0, right? But this one is close to 0.4. 0.4 like close to the median. I think there is I think the answer is yes, right? Oops. Okay, so what do you think? Including the outlier does not change the evidence regarding the linear correlation. Yeah, yes or no? Yeah, currently the answer is no, because you can see this is like really weak correlation, right? So also this one is like weak correlation, right? Because it's 0.3, right? Okay. Because it's like really close to 0. This is close to 0. This is close to 0. Right? So you can see no, including the outlier does not change the evidence regarding of the linear correlation. Okay. You know, like both is still close to 0, right? Okay. Yeah, maybe in your case we can find that the problem will be yes. Okay. If this is improved close to 1 or something like that, or
Yeah,
change to
I
negative. Okay. So
I
you got,
tried to get that one, but I don't, it says it's wrong. I don't know why. In the first one, I got it.
okay.
The RW, I got it, but the RWO, it says it's wrong.
Yeah, you have to change this one. Yeah, okay. Make sure you for the ROW, you need to do like this also. So the correlation will be from a. So don't use the one on the right side here. Okay. Don't use the on the right side here, but using the same data on the left side. Okay. But not include the last data, which is the B B18 and also A18. Okay. Does that make sense?
Yeah, mine shows like it's from K4.
No, you have to change that one.
Oh,
Yeah.
okay.
So you have to change
So,
to A4 to A17 and
okay.
B4 to B17.
Uh,
Okay. If you want to use the K4, you have to copy the data up also for this part. Okay.
okay.
Okay. So I just simply using the same data, but I didn't include the last one. Okay. Yeah, maybe next time I need to change that one. So you
Yeah.
don't need to copy the rest side. Is there any significant difference, like from positive to negative, or from close to 0 to close to 1, something like that? Okay, do you have any other question? Anyone? Yeah, so we, okay. So that's number 12, right? So,
Yeah, number 12.
so because this is not have any difference, so I just no. Because this one is like weak correlation, and also this one is weak correlation, right? Because it's close to 0.
I
Okay.
don't know what's wrong, but it just keeps saying it's wrong, and I changed it.
So you change the data, right? So
Yeah,
the,
I changed A4 to A because my numbers were reaching up to 18.
so up to 18, like this one?
Yeah, yeah, mine
Okay.
was going down up to 18. Then I changed to 18, A18, then B4.
Yeah, so the first one is like from B4 to B18 and
Yeah,
A4 to A18, right? Okay, so this was
yeah,
the one for the with the outlier. Okay. And the one with not without outlier, you need to skip the B. Sorry. Yeah, you need to stop up to 17. Okay, not include the B17 and also A17. Okay,
so
it's not include the B18 and A18. So your data for the without outlier is from A4 to A17 and then B4 to B17.
yeah,
Okay. You got it?
yeah.
Okay. Okay, let's go to number 813. Okay. It will be the same thing. Okay. So number 13. Yeah, so I already put the, you can see if you remember the algebra, right? So you're looking for the x, right? So in order to find the x here, you can see uh, you subtract the y with the b, right? And then divide by the a, okay? So you can see in the, so in this case, you want to predict what value for the explanatory variable. So explanatory variable is just the x, okay? give you a value of 20 on the response variable. So the response variable is the y. Okay. So in this case, you know the y, but you didn't know what is the x, right? So in order to find the y, in order to find the x, you subtract the y with the b, which is 1.156, and then divide by the a, which is 3.783. Right? So you can see here in the Excel for number. Oh, sorry. What is the number here? 13, right? Okay. So number 13 here. So in this case, the y is 20, right? Okay. So you have y 20. The m is the number in front of the x, which is this one, right? 3.783. 3.783. Right? So this is the m. 3.783. And then the b 1.186. 1.186. Okay. So the x will be this one here. So I already put the formula, so automatically you can find the x. Okay. So this is the x. You need to copy and paste it here. And they ask you about one decimal, right? So if the one decimal, that means 5.0, right? And for number 13, yeah, this is the same thing. So in this case, you need to find what is the slope, what is the y-intercept, and then you can find the x, right? Okay. So this number 14. Put it here, right click, paste it, right? So in this case, the y will be 66, right? So the y here is 66. And the m you need to find from the data, right? So you need to see what is the data here. So the data from 3 to 15, right? So from 3 to 15, okay? So make sure this is from 3 to 15. The same thing for this one, from 3 to 15, okay? And your answer will be down here, right? Okay. 13.7. If you want to find in one decimal place, right? So 13.7. Okay, so number 14, 15, right? For this one, you're looking for what is the, okay, so please pay attention for this one, okay? So in this case, okay, the R is really close to 0 because you have R equal to negative 0.137, okay? So for this kind of problem, or for this kind of case, okay, if the R equal to 0, so the best prediction will be the average, okay? So because you predict the response value, so and the average equal to 3.9, sorry, 99, sorry, 39.4. The mean for y is the 39.4. So because the best prediction for the response value will be the mean for the y, okay? Because the I is close to 0. So because the point is scatter all over the place, right? So the best prediction will be the mean, okay? So in this case the mean is for the y is 39.4, okay? Okay, so then number 14, number 15, okay. Number 15, number 16, okay, so let's see. This is talking about the same problem as I believe, right? So let me see if the same data or not. 19.6893.540. Yeah, it's really the same, right? The data, right? 19.6 and the bottom part 28.873.43.30. 46.3, right? Okay, so this is the same thing, okay? But the problem is different. Okay? Let me see here. Compute the correlation between number of wins and cost per wins. Okay. So the correlation between wins and cost per win. Okay. So that means correlation between these two columns, right? Uh, so you need to do here is you need to find the correlation between win and cost, right? So these two columns. So D and E. Okay. So you need to change the correlation here to D and E. So you need to replace this to E, and you already have the D there, right? Okay. Enter. Okay. So this will be your answer. So negative 0.277. Yeah, so sorry, negative 0.277, negative 0.277. Yeah, you have to change because the correlation now is win and cost, right? So you need to change the before. I think you have to like C, so you need to change the C to the E. So you can see here. So the correlation between the A and D. Okay, so 17. Only problem, yeah. Up to step 18, right? So we still have time like 8 minutes. Okay, so we can move it fast. Okay. Okay, in this case, you're looking for the y. So simply like you put the dependent variable here, or the x equal to 30. Okay, and then what is b and what is um, the gradient. Okay. So in this case, the b will be 26.282. Right? 0.282. This is the B, and the M negative 0.596. Sorry, negative 0.596. Yeah, 596. 596. And in this case, is the X is 30. Okay, so luckily the same number here. Okay, but so now let's see here. So the Y will be this one here. Okay. So this will be the Y. And then you want to round up to one decimal place, so it will be this one, right? Okay, 217. Okay. This is negative strong correlation, so the number should be negative that is close to 1. Okay, negative that is close to 1 will be D. Okay, so this is will be D. And this is scattered all over the place, but it's tend to do from the left to the right is like more down, right? So that means this one is close to negative, but that's close to 0, right? Negative that's close to 0 will be C, right? Okay. Oh, sorry. I think this one to tend to put to the right, right? So I think this one is tend to the right. Okay, so I think this one to be the C. Okay. And this one should be the B. Okay. Close to 0, but is from the left to the right is like move out, right? So this is to be the B. Okay. Also, the last one will be the A. Right? Has strong correlation and positive. Okay, so and then the last number will be this one. Yeah, I think we did this for, right? So it's just copy this, and for number, the last one is will be this one. Just right click, paste it, and we don't need this one. So your data is from 5 to 11, right? So this is from 5, sorry, not 5, from 6 to 11, from 6 to 11, from 6 to 11. So this one should be 11, this one should be 11. So the slope is for the slope, and then the intercept is for the intercept, right? So from B6 to B11, and then from A6 to A11. So this will be the gradient. Put it here, and the intercept put it here. And then submit it. Yeah, I think that's all. Okay, for chapter 8 homework. Sorry, for chapter 10 homework. Okay.